All right, number 3. Mrs. Curry is going on a 3-hour canoe trip along a river. 3 hours, that's going to be important. In still water, Mrs. Curry paddles at a speed of 12 kilometers an hour. She plans on traveling downstream, so that's with the water, for a distance of 10 kilometers, then turning around and paddling back as far as she can go in the time remaining, so in the remainder of the 3 hours. Mrs. Curry measures the speed of the current and realizes that she will not make it all the way back. Okay, so the current is either going too fast or too slowly to get all the way back. So how fast can that current be? Well, let's find out. First of all, let's write everything we know. I know we've got a river that is 10 kilometers long. We know she's going downstream at first, so that means she's going with the current at first. We know Miss Curry's speed on the way there is going to be 12 kilometers an hour plus whatever the speed of the current is. We know Miss Curry's speed on the way down, back up against the current will be 12 minus x. And that's because she could go 12 kilometers an hour herself, but she's going against the current, so that'll slow her down. We also know her distance downstream has to be 10 kilometers. And we don't know the distance back because it depends on how far she gets on the way back. We're trying to find what current will it have to be to get less than 10 kilometers back. But we do know that whatever speed she's going times the amount of time will give her her distance, right? If I'm going 100 kilometers an hour and I do it for 4 hours, I'm going to go 400 kilometers. So whatever your speed is times the amount of time is always going to equal your distance. We do know one more thing, that the total time it takes to go there and back, however far he makes it back, is going to be 3 hours. That's in the question. So T1 plus T2 equals 3. All right, so that's a lot of equations. Let's put them all together. Let's rearrange and put them all together and see if we can find one equation with one unknown. So I know that T1 plus T2 equals 3, so let's isolate T2. So T2 equals 3 minus T1. Okay, I'm going to start numbering these equations so that I can use them and refer to them more easily. All right, now that we have them numbered 1 through 8 there, I can say from number 7, we have V2 times T2 equals D2. So we can replace T2 with 3 minus T1. So V2 times 3 minus T1 equals D2. And we'll call that equation number 9. All right, now I want to replace the T1. And if you look at equation number 3, V1 times T1 equals 10. So I'm going to rearrange that to T1 equals 10 divided by V1. We'll call that number 10. Okay, number 9 says V2 times 3 minus T1 equals D2. Well, I'm going to now replace the T1. Eventually, we're going to only have one variable. So V2 times 3 minus 10 divided by V1, because T1 equals 10 divided by V1. And that equals D2 still. All right, since we know that V2 equals 12 minus x and V1 equals 12 plus x, we can rewrite this. V2 is 12 minus x, and that's going to be times 3 minus 10 over V1, which is 12 plus x, and all of that equals D2. And we finally have an equation that's going to tell us the distance back. Okay? Now, the question actually asks us, we want to say, hey, the distance back has to be less than 10 kilometers. So at what speed of the current will that be less than 10 kilometers? So we rewrite this equation as 12 minus x times 3 minus 10 over 12 plus x less than 10. Because we want to know when that distance is less than 10. When it's less than 10, that means Mrs. Curry is not going to make it all the way back. So from here, you're just using all your skills that you learned from rationals. We're going to rearrange this equation a couple of different ways. First, bring the 10 over. Now make it a single rational. Got a common denominator, and we'll just put it all together. Multiply it out and put it all together. There you go, that reduced pretty nicely. And now let's factor it. Negative 3 times x squared minus 64 all over 12 plus x less than 0. Now before graphing it, I'm also going to do another form. I just want to do the division of negative 3x squared plus 192 divided by 12 plus x, just to give us a form that's going to give us our oblique asymptote and remainder. That way we'll know where the oblique asymptote is when we're graphing it. So there we go, and we've got negative 3x plus 36 minus 240 over x minus 12 is less than 0. Alright, so for graphing, definitely the best two equations are going to be, these are inequalities. These two inequalities will be the most useful. The second one here, so that we can easily find the oblique asymptote and also see whether it's going to approach the oblique asymptote from below or above, and this one here to find the zeros and the vertical asymptotes. So we'll quickly let f of x equal negative 3 open bracket x squared minus 64 close bracket all over 12 plus x. Actually, I can factor that a little bit better. Negative 3 x minus 8 x plus 8 over x plus 12. So let's graph it. So at the top you can see the zeros are going to be 8 and negative 8 from the numerator here. And you can see that there's going to be a vertical asymptote at negative 12. And also, if you go back and see this other equation here, we're going to also see we're going to have an oblique asymptote at negative 3x plus 36. We're going to approach that from when x approaches infinity. We're going to get a negative number for this little remainder, negative 240 over a big number. And so that's going to be a small negative number, so it's going to approach from the bottom. And as x approaches negative infinity, we're going to get a little positive number, so it's going to approach from the top. So now if we just go back to the question and our original equations, we want to know basically at what points will Mrs. Curry not get all the way back to the beginning. So at what points will she not make the full 10 kilometers? And the equation we made that was basically saying, is it less than 10 here? So here we're saying, what is this? This is the distance that we're traveling. When is it less than 10 kilometers? Like when will we not make it back all the way the 10 kilometers? And when we subtracted the 10, now we're saying, okay, well, at 0 kilometers, now we're at negative 10 kilometers. And after 1 kilometer traveled, now we'll be at negative 9 because we've subtracted 10, right? So that negative 10, that negative 9, that's basically telling you how far you are from the actual start. So when we graphed it, we can see at f of x is negative 10, well, that's where you're going to be basically at the turnaround point. Where f of x is 0, that's when you've gotten all the way back. If f of x is a positive number, then you got more than the way back. If f of x is a negative number, you didn't quite get back. If f of x is worse than negative 10, that means like the river was flowing so fast that you couldn't even start coming back. When you turned around, the river's current was too fast for you, so you actually kept going backwards. So let's say the river's current is 13. Well, you'll have no problem getting the 10 kilometers, but when you turn around, you'll still be going a kilometer an hour backwards, because 13 kilometer an hour current is going to still be taking you backwards when you're going 12 kilometers an hour towards it. So you're going to actually end up 2.6 kilometers farther than the 10 kilometers in the end. So you'll end up at negative 12.6. And it gets worse and worse as the current gets worse and worse. Okay, so to answer the final answer, the question is where are the spots where it's going to be bad, where she's not going to get back? Well, that's all the blue area here. Okay, so the final answer is the current must have been anywhere between negative 12 kilometers an hour and negative 8 kilometers an hour, or 8 kilometers, anywhere above 8 kilometers an hour.